Hi everyone, this is Mrs. GA, and today we're going to learn about the properties of parallelograms. So the definition of a parallelogram is a quadrilateral, meaning a four-sided polygon that has two pairs of parallel sides. So we can show that this is a parallelogram by making these little carets, which show that the opposite sides are parallel, and then we're going to do maybe a double caret to show that this pair of opposite sides is also parallel, but make sure the symbols are different. So this is the definition of a parallelogram. So one piece of vocabulary we're going to be using a lot in this module is the word diagonal. So the diagonal of a polygon is a segment that connects two non-consecutive vertices. So non-consecutive is the important word here. What it means is pretty much not next to each other. Okay, so for example, this angle and this angle are consecutive angles, so this would not work to make a diagonal. So it connects two non-consecutive vertices. So this would be one example of a diagonal, and this would be another example of a diagonal. So we're going to be coming back to different uses of our diagonals throughout this entire module. Okay, so there are three theorems about parallelograms. So if you know that a quadrilateral is a parallelogram, there's three useful properties that we can state. So the first one is, if a quadrilateral is a parallelogram, then its opposite sides are always going to be congruent. And we can show this by marking with tick marks, so I know that this pair of sides are congruent, and so are these two. So that's one fact that we know about parallelograms. The next one is, if a quadrilateral is a parallelogram, then its opposite angles are also congruent. So we can mark that with our little arcs. So these two opposite angles are congruent, and we'll use a different symbol, maybe a double arc, to show that these two are also congruent. And last, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And remember, this word bisect means to cut in half. And that means perfectly in half, so creating two congruent segments. So if I have my two diagonals like this, we can show that they bisect each other by showing that this segment is congruent to this and that this is congruent to this. So you can see this diagonal is cut into two congruent parts. This diagonal is cut into two congruent parts. Please note that we are not stating that the two diagonals are congruent. We're not stating that these segments are congruent. The only thing we can state with parallelograms is that the diagonals bisect each other. So make sure that we're not overgeneralizing with any of these properties. Okay, so now using these theorems, we're going to see if we can solve these different problems. So for example 1, the first thing they note is that A, B, C, D is a parallelogram. So it's really important that we know this fact. So either they need to state it or it needs to be shown in the picture, or else we can't use any of those theorems we just learned. So the first thing they ask us to do is to find AD. So I see that AD is a side length. So I'm going to first state the theorem that will help us solve this problem. So we know that in a parallelogram, opposite sides are congruent. So that means I can make the general statement that BC is congruent to AD. So that allows me then to make the more specific equation that 6x is equal to 4x plus 12. And then I can subtract 4x from each side, and I get 2x equals 12, so x equals 6. Now be careful that we're actually completing what they're asking us to find. They don't want to know what x is, they want to know what AD is. So then here we'll set up our statement, and then all we need to do is substitute. So we're going to substitute 6 for x. So we get AD equals 36. So again, we're always going to start by stating the theorem that we're using, and then a general statement, and then a specific equation. Okay, so for part B, they're asking us to find the measure of angle B. So we know that one theorem about parallelograms is that the opposite angles are congruent. So that allows us to make the statement that angle B is congruent to angle D. Of course, we could also say that angle A is congruent to angle C, but that doesn't really help us find what they're asking. So we're going to make that statement, and then we can make the more specific equation 5y plus 14 equals 7y minus 12. So I can subtract 5y from each side and also add 12 to both sides. And if I divide by 2, we get y equals 13. Again, they don't want to know what y is equal to. They want to know what angle B is equal to. So we know that angle B is 5y plus 14, so we can substitute. So we end up with angle B equals 79 degrees. Okay, so now let's look down here at example 2. So again, here we are told that PQRS is a parallelogram, which is really important. So we know we can use those theorems we just learned. And the first thing they're asking us to find is PR, which you'll notice PR is a diagonal. So you have to ask yourself, well, what do I know about the diagonals of a parallelogram? So we know that the diagonals of a parallelogram bisect each other, which means they cut each other into two congruent parts. So that means that we know that this segment is congruent to this segment, which allows me to make the general statement that PT is congruent to TR. So now I can make a more specific equation, which will allow me to solve for x. So I can add 6 and subtract x, so we get x equals 5. And then for us to find PR, make sure you're careful because PR is the entire diagonal. So we can make the statement that PR is PT plus TR. So that means that PR is x plus 9 plus 4x minus 6. So now we can substitute x with 5. So we have 5 plus 9 plus 4 times 5 minus 6. And that leaves us with PR equal to 28. Okay, and in this last example, they are asking us to find the length of segment PS. So again, this is a side length. So I say, what do we know about the sides of a parallelogram? We know that the opposite sides are congruent, which allows us to make the general statement that PS is congruent to QR, which then allows us to make the more specific equation, 5z plus 3 equals 6z minus 3. So I can subtract 5z from each side, and I can add 3. So I get z equals 6. And then, of course, they don't want to find z, they want to know what PS is. So PS is 5z plus 3, so we can substitute. So 5 times 6 plus 3. So we get PS equals 33. So again, as you're going through problems like this, make sure you start by stating the theorem that you can use to help you solve the problem, and then go for a generalist statement, and then you can set up your equation. All right, that is all for today's video. Thank you so much for watching.